Alright guys, today's goal, the learner will understand extended trigonometry. They're circular functions, okay? Alright, so quick review here. Give the value of the angle in degrees if, so times 180 over pi. So 2 times 180 divided by 3. So that's 120 degrees. Negative pi over 4, negative 45 degrees. You can get it the same way, but that's pi over 4 you're going to memorize is 45 degrees. So, cotangent. Use special triangles to evaluate. Well, cotangent of negative pi over 4. Remember, cotangent is the inverse of tangent. And the tangent of pi over 4 is 1. And cotangent is the same thing as 1 over the tangent of negative pi over 4. So that'd be 1 over negative 1, so negative 1. Cosine of negative 7 pi over 6. Well, that's a negative 210 degrees, so it's a negative 30 degree angle. So, or it's going to be, this is just these are things we need to be able to figure out without a calculator. Negative 7 pi over 6, we'll be going over this today, but this should be review as well. But it'd be negative 210 degrees, so it'd be negative square root 3 over 2. Because that puts us here, forms that 30 degree angle there. So it's yx. It's the longer side of a 30-69 triangle, and it's negative though, so it's negative square root 3 over 2. Use the right triangle to find the other 5 trig functions of the acute angle given in cosine 4, 5. Adjacent over hypotenuse. Use Pythagorean theorem to get the other side, and it's 3. So now you get sine of the angle, 3/5. Cosecant then, 5/3. If the cosine of the angle is 4/5, the secant, 5/4. Tangent of the angle, 3/4, so cotangent, 4/3. See if we're right. Yep. Okay. So what you're going to learn about trig functions of any angle, trigonometric functions of real numbers, periodic functions, and the 16-point unit circle, and why extending trigonometric functions beyond triangle ratios opens up a new world of applications. An angle, initial side, terminal side. So when we start talking about the unit circle, every time the initial side is the 0 degrees, right here. And then positive direction, negative direction, okay? Positive angle, negative angle. Positive, negative angle, okay. Quadrant 1. This is how I remember this, okay? A, smart, trig, class. Or another one, all students take calculus. So the A stands for all, meaning all of them are positive. Student smart. What does it begin with S? So that means sine is positive. Well, if sine is positive, so is cosecant. Trig, well, what main one begins with T? Tangent. So tangent is positive, so is cotangent. Then the rest are negative. Class, cosine, or secant. The rest are negative. Okay? You will need to remember that. Coterminal angles. Two angles in an extended angle measurement system can have the same initial side and the same terminal side, yet different measures. So if I said an angle of 20 degrees and I wanted a coterminal angle, well, think about the circle. There's the 20 degrees. How far would I go around? All the way around. So add 360. So 380 degrees would be a coterminal. Okay? So, or you could subtract 360. Find a positive angle and a negative angle that are coterminal with 45 degrees. So you do 45 plus 360. So that would be 405 degrees. And 45 minus 360. Negative 315. Negative 315 degrees. There's one, there's another. Okay? There we go. So how do we do it for pi over 6? Well, 360 degrees is equal to 2 pi. Excuse me. So you get pi over 6 plus 2 pi. Pi over 6 minus 2 pi. So this would be 13 pi over 6. And then this would be negative 11 pi over 6. Now I did a lot in my head, so I could have made a mistake there. Let's see. Nope, we're good. Okay. So, trigonometric functions of any angle. Let theta be any angle in a standard position. Let P, the point x, y, be any point on the terminal side of the angle, except the origin. Let R denote the distance from the point x, y to the origin. Let R equal the square root of x squared plus y squared. Now watch, this is why. If I look at just quadrant 1, and that's the point 1, 2. Couldn't I say that's a side length of 1, that's a side length of 2, and use Pythagorean theorem to solve it, which is exactly what this is. Okay? But only when x and y can't be 0. So it says, let theta be the acute angle in standard position whose terminal side contains a point 35. Find the 6 trig functions. So, first thing I look at. So I know this is 3, this is 5. See how that's a right triangle? So R equals 3 plus 5. 3 squared plus 5 squared square rooted. 9 plus 25. So R is the square root of 34. So now we have to do sine, cosine, tangent. Well, sine is opposite, and we're looking at this angle. Opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Remember I said don't worry about simplifying these, so I'm fine with all of these as answers. Now do cosecant. flip it. Secant. Cotangent. So there we go. Okay. Yep. I was just doing exact answers, so. Evaluating trig functions of non-quadrantal angle theta. Draw the angle in standard position, being careful to place the terminal side in the correct quadrant. Without declaring a scale on either axis, label a point other than the origin. Draw a perpendicular segment from P to the x-axis, determining the reference triangle. Okay? So just like what I was doing before, except it's not standard. Okay, so watch. So find the calculator find sine of 210 without a calculator. Okay. Well, there's 90, 180 degrees. So I look at this. Here is the theta I'm looking at. And that's 30 degrees. So the sine of a 30-degree angle. 1/2. The cosine of a 30-degree angle. Well, we're not dealing with 30, so hold on. So now we're doing the sine. Oh, we just need sine. I was doing all 6. We just need the sine of 210. Well, the sine of 30, which is the equivalent of that, is 1/2. And then you do a smart trig class. So tangent is the only thing positive, so it's negative 1/2. Okay? So what they were talking about over there by making the triangle was here's the negative 210. But see how if we do this to the x-axis every time, you always do it to the x-axis. So now you can see that's 30 degrees because you have 180 plus 30 left over. Okay? Yep, negative 1/2. So find the sine, cosine, given that the tangent of theta is 4/3, and that the cosine of theta is less than 0. So that means cosine is negative. Okay, well, where is tangent positive and cosine negative? Quadrant 3. So now here's the thing. Remember, tangent is the y over the x. So we're looking at this triangle. That's 3, that's 4, so that would be 5. So the sine of that angle, negative 4/5. The cosine of that angle, negative 3/5. Okay? That goes back to the previous table, or we just need to start realizing. And here's another thing. On the unit circle, any ordered pair is always cosine, comma sine. Okay? Let's see if I was right. There we go. The unit circle is a circle of radius 1 centered at the origin. See how it says y equals the sine of t, x equals cosine of t? That's why, like I was saying, cosine t comma sine t. Y over x, x over y, okay? A function y equals f of t is a periodic function if there's a positive number c such that f of t plus c equals f of t for all values in the domain. The smallest such c is called the period of the function. So what are the period of the trig functions? The period of sine 2 pi. Period of cosine 2 pi. Period of tangent is just pi. These are things we're going to need to know, okay? These are very important things. Now, if the sine is 2 pi and the cosine are 2 pi, that means cosecant and secant are also 2 pi because they're just inverses of each other, okay? All right. So evaluate by using the pi period of the function. All right, so we have the sine of pi over 6 plus 49,000 pi. Well, I want to divide that by 2 pi because that's a period, because that'll tell me how many times I go 2 pi. Okay? So let's think about it this way. We have sine of pi over 6 plus the sine of this but I know the sine of 2 pi equals 0. So as long as this is a whole number, which we know it is, so this is 0. Because here's the thing. Unit circle. There's 2 pi. What's the y value right there? 0. Sine of pi over 6 is 1/2. So what's 1/2 plus 0? 1/2. How am I getting these? I'm using the unit circle, not my calculator. So let's take a look at the unit circle. Here it is. This is what you need to know. And remember, cosine, comma sine. So see how I said the sine of 0 was 0? Or 2 pi was 0? Sine of pi over 6, 1/2. Okay? You need to memorize this. Bottom line, you will not be given this on a test. Memorize it. Use it. I'm going to give a quiz where that is blank and you have to fill it in. Okay? Be ready for class tomorrow.